Hey, just give me a second. Okay, so thank you for coming. We'll be doing a hands-on session on sparkling water. My name is Jakub Hava. Some people call me Kuba. I'm software engineer at H2O. And we'll be using Python for today's demo. You don't need to install anything. We'll be using the quick labs. I don't know if you tried that before in previous sessions, so that should be smooth. Before we go ahead, before I start explaining what we're gonna do, what the demo will be about, I would suggest that we first set up the quick lab because it can take up 10 minutes for everybody to have the environment ready. So if you can follow up these steps with me, go to h2oquicklab.com. Also, if you have any questions, you can ask. There are H2O folks around with makers gonna make t-shirts or H2O makers t-shirts, and they should help you with the setting up the environment. And I can maybe help you as well, like for following 5 minutes, just to make sure we are running. So you just need to go to the page, and there should be a big button called Join. You need to register before, so if you are using Quick Labs for the first time, just register. You need to put there your name and email. I promise it won't spam you. It's really safe to put there your mail. Okay, so let me have a look. So if people already have a quick labs running, just raise your hand or say something. Okay, awesome. Then you can follow up. We'll be doing the sparkling water session. So if you click on the grid right on the left top corner, it should show you all the available sessions, and there should be sparkling water session. You can choose. Can you see that? So I can try to do the steps as well, so you see how it looks. So I already have the account. Oh, sorry, was that a question? Oh yeah, I just wanted to help people to reproduce all the steps. Yeah, so the only information you need to have this h2o.quicklab.com URL. Then you should be fine. So let me just quickly show you how it looks. Let me go here. Let me sign it. This is what you see. You will click on this catalog thing in the left top corner, and there will be lab for you. There will be lab for you sparkling water in Python. We have 57 minutes for this lab. The quick lab will be killed after this time. Also, please make sure that you will stop the containers before you leave this session, so other people can use them afterwards. So there are other steps when you are in the quick labs. You just need to click on the button Start Lab, and it will spin up the environment for you. And on the left corner, there will be URL. Just be sure you won't replace this tab. Just open the URL in the new tab, and just wait for it to come up. You can just keep refreshing, and it will give you Jupyter Notebook. Is anybody there already with Jupyter Notebook? Okay. You can use password H2O to come in, but before you execute anything, just please wait. Okay, so we give it another 3 minutes. Anybody needs help with setting up quick labs? I can help. Okay. If you, for some reason, don't get the quick lab running, there we have some limit for like all the quick labs we can run at the same time, which should be fine in our case. But if somebody hits the issues, we can run it later. That's fine. And also, you can open the example here on GitHub. Yeah. So once you get into quick lab, you will see this page. This is the password, H2O. Oh, yeah. Yeah, there are two buttons in the left top corner. Just make sure you click on the grade, not the total up button, because it just opens the menu, and you won't see the lab. So just click on the grade underneath of the button right on the top. Okay, I will check one more time. How many Jupyter notebooks do we have running? Okay, it's getting better, so just be patient for a bit for others as well. We'll start real soon. Like, you can also, for people who just joined, you can follow up the steps like during the talk. It's Jupyter notebook, so the code you don't need to change the code. It's all there, so you can join anytime. Yeah, so let's give it another 2 minutes, and we'll start with the demo. Yeah, for people joining, if you want to follow up with this course, just go to a webpage called h2o.quicklab.com and follow up the steps here. You can also ask people next to you, like if they have QuickLab already running, so they can help you. And we have H2O folks available to help you as well. I just see one question here. I can answer it right away. This won't be Databricks example. I'm not going to use Databricks cloud right now. Okay. Okay, so how does it look? I will continue with the presentation. So how many people have Jupyter notebooks running? Okay, that's good for continuing. So please, everybody else, just continue setting it up. So let me first introduce Sparkling Water project. So there is lots of people behind what we do. Michal Malhlava, he's helping right there. He is Chief Platform Architect at H2O, and he's the creator of Sparkling Water. So he's the big guy behind this project. I'm software engineer at H2O. I'm working on it for almost 3 years as well. So we are working on it together. We have also Navdeep Gill. He's the author of the R Sparkling. It's a Sparkling Motor API to R. So this also helps people who are using RStudio or R in their production. And we have Michal Kurka. He's a head of H2O and senior engineer at H2O. Because without H2O, there won't be any Sparkling motor. We integrate Spark and H2O, and we highly depend on H2O algorithms, H2O code. Let me introduce also Sparkling motor roadmap. So what's ahead of us? We have a few features coming. For Kuba 1, we plan mostly stability fixes and upgrades to H2O and Spark. So making sure that we use all the features with latest Spark 2.2 that we integrate nicely. We also plan to do some stability fixes. We would like to improve some heartbeat issues, which we see in really environments with high workloads. And we would like also to integrate Steam. Yeah, if it's a question regarding the setup, just please ask anybody here. Just raise your hand so anybody can see you. Yes. So we plan also to integrate enterprise Steam, which means that you will be able to start Sparkling motor clusters from our Steam manager, and you can manage Sparkling motor clusters in the same way as H2O clusters. For Q2, for the second season, we plan to support driverless AI mojos. So that means that the pipeline you export from driverless AI as in the form of mojo, you will be able to load it in Spark and execute it in PySpark or Scala. So that's the plan for Q2 and telemetry, which means that we would like to instrument Spark. We would like to put H2O internal information to Spark debugging process. So people who are using Spark and they are using Spark instrumentation and monitoring, they can also see this H2O internal stuff. So it's good for debugging. You could turn this feature on, and it will just collect some information of the H2O runtime, which we can use for debugging, which is really helpful for cases which depends on the environment and specific solutions. And just pipeline improvements, which means making sure that in Python and Scala we have all the consistent arguments in pipelines. And for the last 2 quarters, we plan to integrate better with Spark and expose more H2 algorithms in a Sparkling motor. Right now, everybody can use all the algorithms we have, but they are just not wrapped inside of nice APIs. So what we want to do is to create small nice wrappers around other algorithms such as k-means and other algos. So just quick introduction to Sparkling motor, and then we will go ahead and start the demo. So what's Sparkling motor? Maybe actually, have you heard of Sparkling motor before? Okay, cool. So it's an integration of H2O and Spark, and what we want to do is to create seamless integration between these 2 applications that people can, who are used to use Spark, they have already Spark pipelines in their environment, they can use H2O machine learning tools inside of Spark. So that gives them really possibility to replace Spark ML, because we think that we can do better at some problems. So they can use our tools. But we really try to make this experience smooth for Spark users. We have the ecosystem. We support all major languages. Sparkling motor is written in Scala, the core of it. And you can also see some calls how you can create Spark context, which is object which orchestrates the communication across the Spark cluster. And we extend it in H2 Sparkling motor as a H2 context, which is exactly almost the same thing, but just for H2 nodes in the Spark cluster. And you can see that the calls are very similar across Sparkling motor in Scala, PySparkling in Python, and R Sparkling in R. So benefits, Spark, so far, it's really good for data managing features. We are still catching up with H2O, but some people prefer to do data managing still in Spark. And then they can switch to H2O and run the algorithm, run the training process there. We also have a flow interface. And just really, I'll mention this real quick because I don't want to talk that much about architecture. In Spark and Water, we support two kind of backends. Maybe you already heard of it on a previous talk by Luca and Ben. They were talking about external backend. So we have an internal backend. When we run H2O nodes inside of Spark cluster, this is easy for you to deploy because you don't need to care about setting up another cluster. It's just when you call H2O context get or create, it will start H2O inside of Spark. It's easy peasy to start. And we have an external backend, which is a little bit more complicated to set up, but we provide some nice wrappers on Yarn, so you don't need to do much. And we need to spin up a separate H2O cluster, and we just connect to it from Spark. Like these two backends, each has some advantages, disadvantages, but I would like to spend more time on the example than explaining the technical details. So we can also discuss it later after the talk. And let's do the demo. Just quick check, how many people already have a Quick Labs? Is there more of people? Okay, it's getting better. So what we're going to show is that we will show how we can train the pipeline in PySpark. So we will use the Python language. It's good for data scientists because they are not that familiar with Java or Scala. So it's easy and nice to try things out in Python. We will use Jupyter for it. And we will create a pipeline which will contain all the data managing and training steps, and we will export it in a language-independent format, and then we can use it. We will show how we can use it in Scala, in JVM world, to run streaming predictions. So this is like we can see that we can really nicely productionize sparkling water. You can let your data scientist define your pipeline, then you can export it, and you can productionize the same pipeline in Scala or even different languages you prefer. Yes, and let me go to Jupyter. Yeah, so when you open the Jupyter, you should see, I'll make it bigger. Can you read it? Can everybody read it? There should be additional screens in the corners, so for you which are far away, you should see it there. So I think I'll almost cover what we're gonna do. It's in the background. You can execute the cells by doing Control Enter. It will execute the stage. In case of documentation, it won't do much. Yeah. Oh yeah. I didn't say that. Yeah, when you that's a good point. When you get the Jupyter notebook, you need to click on Python folder, and there is a demo called Amazon Fine Foods IPNB whatever the Amazon Fine Food Pipeline. Yeah, that was a good point. Yeah, and as the name suggests, we will be using the Amazon Reviews CSV file for this demo. What we're gonna do is that we will try to predict sentiment. So this file contains several columns. For us, the most interesting is date columns and summaries and scores. And what we want to do is, based on the summary and date, we would like to predict whether the summary is positive or negative, whether the experience on the restaurants was negative or positive. And why the date column is important? Because it might influence the resultant model as well. For example, people may tend to rank restaurants higher on Fridays because they finish with their work and there is weekend ahead of them, and they might be not happy with Mondays or something like that. So the date can also influence the model itself. So we don't just use the summary. And once we have a pipeline, we will productionize it. So this is just architecture of demonstrating what we're gonna do on a picture. We will train the pipeline offline, and then we will we will deploy it online in Scala. So the first code, I'm going to execute this. I'm going to make sure that we have a Spark session available. In Spark 2.2, there is the Spark session. For people who are familiar with Spark 2 and older, there was a Spark context call. Spark session is very similar. It just wraps also SQL context. So it's a nice wrapper for you. And just click Control-Enter, and it should give you Spark session. This works. You don't need to do any other additional calls because this Jupyter is configured with the Spark kernel. And when you run this, it understands this Spark variable. And when you run it, it will just spin up the cluster for you without no additional changes. So this will take a while. It can take like 1 or 2 minutes to get a Spark session. So just be patient with this call. It can take a while. Also, nice thing about the Spark session is that you have also all the SQL tables registered in the Spark session. You don't need to take care of managing different SQL contexts. In previous Spark versions, it's nicely managed behind one Spark session object. Okay, just give it a second. Yep. Like once we have Spark available, like it's already available. We don't need to. It's better to wait for this call to finish. Once we have this call, once we have a Spark running, we will continue with setting up H2 context. So for people who already have have this cell finished, just go ahead and start the next line because that line can take also just some time. So just that we have all set up. And what this call does is that we will just import PySparkling. It's a Sparkling motor library for Python, and we will ensure that we will start H2O nodes on each Spark executor. Okay, have the Spark call for people who are trying the quick labs already finished? I'm just checking. Okay, so we are still not there yet, so. Yeah, sometimes it also happens to me in Jupyter that even though the cell finished, you don't see the output and it's still marked with star. Sometimes that happens to me. What is the reviews.csv file? Yeah, I'm gonna get to that stage. So you already have a Spark call finished for you. You have already H2 running inside of that cluster. Okay, I assume you're good to go. Okay, this seems to taking unusually long. So let me go to quick labs. Okay, so it's the same thing. I'll just got myself a clean quick lab, so let us run it here. Awesome. So we have you should get this when you get the Spark session. The version, the master variable specifies in which modes you are running. In our case, we are just using local mode, which means just one single JVM. We can proceed with creating H2 cluster. So as I said, this code just goes around the cluster and it will spin up H2 node on each node in the Spark executor. So this can take up to, oh, it was really fast. So you can see all the information here, how old is the cluster, what the version is of the cluster, the name, the URL you can go to Flow UI. Just please make sure, because we are running on underneath of it, these are EC2 machines and behind proxies. So just if you want to go to our user interface flow and have a look on it, just replace this IP address with the IP address you have here in your URL tab. But we don't need flow for this session. So this is just if you want to see how it looks like. So now we should have H2 cluster running and all set up, and we can import the data. We'll be using the Amazon Reviews CSV file. So for this we need to import H2O library, and we will use a method called H2O.upload file, which will just upload the file to the cluster and creates a H2 frame out of it. And the second argument specifies how we're gonna name the cluster, the file. So if you don't specify the name of it, it will be just named like Amazon Reviews _train and some arbitrary numbers. It's easier to work with if you have nice names. So this should upload a file for you. The file is around 300 megabytes big. And I pre-splitted it for training purposes and for prediction purposes. So, has anybody already finished this stage? Okay, cool. Now we can go to Flow, and I will show you that we can actually see the frame there. So I can click on this, but I can click on this, but you see that this won't work because I need to change the IP address. So just let me copy it here. Okay, so we have a flow running. It will just take a while to properly show up.
You might want to tell them to use port 54321.
Oh yeah. The port it's printed here. If you click on this link, it will give you the port. But if you want to type the URL yourself, just use the URL you have right here and change the port to 54321, and this will give you the flow. And what we can do is click on data and do list all frames. And we can see that the reviews.hex file is right there. We can also click on it. We can build a model on it. We won't do it from Flow. We will build a model in Spark, in PySpark. But we can see the data here. We can see all the features we have here. And you can see also nice summaries which are available in the frame. So I'll just wait for 1 minute, maybe like half a minute. In Spark Motor, you can also create so-called Scala cells, and you can execute any Scala code you want in Flow UI. So the Scala cells are black, so you will definitely recognize if it's a Scala cell. And you can call any Spark code, any Scala code. So for example, I can just run 1+1, and it executed. Wow. I can also get Spark information here. You have Spark session running. Okay, so let me switch back to let me switch back to the Jupyter notebook. So we have data already available in a frame called reviews underscore H2O. And we already had a look on it in H2O flow, where you can really nicely see the layout of the data. And we can continue with the pipeline. So what we need to do is that the Spark pipelines, they accept Spark data frames. In H2O, we have so-called, in Spark Model, we have so-called H2O frames, which are differently structured, differently compressed. And when we need to do something in Spark or H2O, we need to switch between these two formats. So right now we have a H2O frame, but we want to execute Spark pipeline. We need to switch this data frame, Spark data frame, to H2O data frame. And this is for this we can use the call spark frame, which is available on H2O context. And you just pass it one single argument, which is the H2O frame. Okay, it should be really quick. Because how Spark works, it works in a lazy way. It doesn't execute a command right away. It just waits for you when you first need the data. So for example, if I would call count right here, or collect, it would actually materialize the data and execute stuff. But right now, I just told it, okay, this is the data frame I want to have later.
I'm getting an error. H2O frame object has no attribute underscore Java frame.
Yeah, maybe can somebody have a look? Maybe Jorge. Have you changed anything in the notebook or? Okay. Jorge, can have a look. Awesome. Yeah. So just raise your hand. I won't be answering like all the errors we're gonna have. So just raise your hand, and somebody from H2O folks will come to you. Maybe. Oh yeah. So let me continue. We will gonna do take number 1. Because when we're gonna use this pipeline as part of streaming pipeline in production, we don't have information about scheme, because there will be just one rows coming to us, and there is no information about scheme. What we can do right now, we can export the scheme when we train the pipeline offline, and we can reuse the scheme for the data coming from some online sources, because it's really hard to determine type of data in case you have just one single row. And for this, we will use we loaded data using H2O. We didn't load the data right away using Spark, because we think that H2O does a pretty good job at determining the types. It sees the first few thousand lines of the data, and it will just determine what can be the type of the data. So I will export the schema file. I will export the schema to a file called schema.json. I can get a schema on Spark object by calling .schema.json. And we will start defining all the stages for the pipeline. So how it works in Spark with the pipelines is that we have two pipeline stages, two generic pipeline stages. They are called estimators and transformers. Transformers, they are used to transfer the input data source. So let's say you have an input data source with one column. The transformer can create a new column which somehow transform the original column. You can, for example, split the data. You can remove words you don't want to have for your modeling and things like that. And the estimators, they are used for fitting the models. So when you use estimators such as H2 Jbm estimator, you can call fit method on it, which will create H2O model, which is actually transformer again, because you can give it input data and it will transform the input data, and it will apply the prediction function on it, and it will give you new frame with the resulted predictions. But also just technicalities, you don't need to know it, you just need to know how to run it, and that's fine. So the first, let me start with defining the pipeline stages. So the first stage I'm gonna start with is SQL transformer, which you can use in Spark to execute any SQL code as part of Spark pipeline, which can be really useful if there is a lack of other transformer. For example, we have transformers for hashing TF, stop words transformer, But if there is a lack of some transformers, you can use this universal transformer to execute the code. So what I'm doing here is, maybe I can make it bigger. Yes, this is better. So what I'm doing here, I'm just importing the SQL transformer, and I'm defining the stage, which is named call select, and I will select the score, the time, and the summary from the reviews data set. This underscore this underscore just specifies that we want to get the data from current frame. So when I execute this, no code will actually be running, be executed. I'll just define the stage. Also, I need to call this Spark SQL function called from Unix time, because right now the time is in a timestamp since the start of the epoch. But I want to have it in a more human-readable format. Okay, there will be, I guess, some errors, but are we still catching up? At least a few of us. Good. We can also do trick number 2. And usually, when you define all the stages for the pipelines, they are executed when you call pipeline fit and pipeline model. Pipeline transform. But you can also inspect the data right away by manually calling the transform method on the pipeline stage. So what I'm doing here, I'm calling transform method on this transformer, and I'm giving it input frame reviews Spark, which is this frame I just created here from H2 frame. I can execute this code. And I can also have a nice peek into the data. I can see there are 3 columns, score, time, summary. 5 means good, 1 means it's really not that good, you wouldn't go to that restaurant. You can see the date when the review happened, when it was published, and the text of the review. Okay. Then we can continue and define the other transformer. We will still use SQL transformer because I need to refine the date column. Right now, the date column is it's still internally stored as a timestamp since the timestamp, but it's just printed as in a nice human-readable format. What I want to do is create several new columns, which will be, for example, day in a month, year, if it's a weekend or not, what season is that. And for that, I'm using, again, the SQL transformer and a bunch of Spark SQL methods. So it's really nice in Spark that if you need to do something unusual or you need to touch Spark SQL, they will have like all these methods available. I don't need to play much with it. So we have methods for day of month, week of year, date format. You can give it any format here, and it will just transform the date to the format you expect. Here I'm checking if it's either Saturday or Sunday to check if it's a weekend, and this last call, it just determines what the season is, if it's winter, spring, summer, or autumn. And I'm again using the output of the previous stage, which is specified by this. Okay, and we can again transform the data. Oh, I didn't run this stage. And I can see I added just a bunch of new columns with the information I just created. Okay, the other stage we're gonna use is again SQL transformer, but what we wanna do is we are interested whether the review is positive or negative. We are not interested in the exact score. So I'm gonna create a new column named sentiment, and I will remove the neutral reviews, because the reviews neutral, they don't give me much information for my model right now. So let me just define this stage. I can again inspect the data right away. You don't need to do these calls afterwards. You will call it inside the pipeline. This is just to see the results right away. And it filtered out the columns which had the score 3, and we had the sentiment instead, negative, positive. Let me define it. Tokenizer, what this call does is that it will take the summary and it will split the summary into several words. So it will split this one sentence into several words. It will create actually array out of it. So we can see that we have an array of words. Good quality. It just split the words based on this regex. It split it by comma and space. The next stage for our pipeline we need to do is to remove unnecessary words. So this is again Spark transformer, which is called stop words remover, and we will remove not important words such as articles, prepositions, and words like that. We can again have a look on the data. Yeah, for example, you can see that the S was removed. Now we will hash the words because it's easier to work with numbers, and you can either use hashing TF call or count vectorizer. They are doing the same thing, except that the count vectorizer also stores the information about the word index mapping, so that you can actually later have a look and see which words are backed by those indices. So that might be helpful if you want to match some features in our H2 frames with like data right away. I will show that on the example later. So we will hash the words, and important to set up here is the min_df argument, which specifies that we are just interested in words which occurs more than 100 times in the data, because we are not interested in the outliers. We don't want outliers to influence our model. So let me manually, the count vectorizer is actually a model, so I need to call fit on it first. And I can see the vocabulary size. I can see that there is 1,500 words. And this is just first 10 words from the vocabulary. Great, good, best, love, coffee, just first 10 words. And I can train data on this count vectorizer model as well. And the output is that we have a vector, and this position specifies that on position number 1, we have a word good. On position number 10, we have a word quality. Actually, it specifies that on position number 10, we have a word which is on the position 10 in the vocabulary. Okay, the next stage I need to do is to call tf_idf, because I'm interested in how much the word is important to the data. And that's exactly what tf_idf does. You can go ahead and open the link right here, and it will point you to Spark documentation, where it's really nicely explained. Basically, it calculates some logarithm, and it just does some magic with numbers, and it will calculate how the word is important to the corpus. I can again, the IDF returns a model, so I need to call fit on it first. Again, in pipeline, we don't need to care about that. It's done for us. And I can have a look on the data. So we can see it's very similar, because we just see the start of a sparse vector, but the second part of the vector will be different, because we will have the importances there. And we are almost done with defining the pipeline. Right now, I need to remove the summary column, the textual information. And that's important because the algorithms get confused if we pass them textual information. That's why we converted the data into numbers using the IDF and tf_idf calls. And right now, since we already transformed them, we can get rid of the textual information. So I again use the SQL transformer, and I can see that I don't have a summary anymore here. And finally, we are getting to the interesting bit. We can execute H2 Jbm model as part of this stage. You can see that the call is very similar to the calls defined previously. So we really try to have the API unified, so people don't need to care much about if it's Spark or H2O. And I will run H2 Jbm on the model on the data I just defined above. So this I just defined H2 Jbm. And finally, in the next stage, I can define the pipeline. And here I just list all the pipeline stages I just created. And I wrap them inside one pipeline call, one pipeline object. Okay, are we still good with this? Cool. Underneath of it, the H2 Jbm pipeline model, when it's fit, it's not exported using binary model. It's exported using Mojo, and that's a big advantage. That it doesn't depend on H2 runtime, and you can actually execute it in any environment you want, and you don't need to have H2 cluster running for actually do the predictions. And you can use them from Python, R, Scala. It's really a version independent format. So let me go back here. And I will actually train the model. I will actually fit the model. And what this call does, it goes over all the stages I just defined, and it will execute the transformers, and it will run all the estimators and train the models. So that's why I need to pass it the input frame. The original one I just created up there. And you don't need to do any of the transform methods which I did above. It was just for testing purposes. So this is what you need to do only. This will take a while. It can take up to 3-4 minutes because we need to train H2 Jbm with 53s, which is the default. So before it finishes, let me just go ahead and explain the later stages. Once we have the model, and I will rerun them when I have the model available. The next thing we need to do, what we would like to do, is to try some predictions. So what I do here, I load again using H2O Amazon reviews _ predictions CSV file. I name it with like my name I want, and I create this H2 frame. Again, I'm simulating the steps I just did above for the training data. I'm converting the data into Spark frame because I want to input this data to the pipeline. It expects a Spark data frame. And on this model, this pipeline model, I can execute the transform method on these predictions, on this Spark data frame with data I want to predict on. And what it will do, it will execute again each transform method in the pipeline, and it will run the predictions on the models created by the pipeline. So what the data scientists just need to know is that they need to define their stages. They just need to call this pipeline fit method on the input data. It will transform the data, and then if you want to train the model, do the predictions on pipeline model, you need to call this line of code. And you don't need to do any pre-processing before. That's the nice thing. It's all executed in one single pipeline. This is just a peek into the data. You can then export the pipeline model using this call, and you can export it into a file or directory called reviews pipeline model. And then we will reuse it to demonstrate how we can use this from streaming application. How does it look? I think it will be still running. Yes. Once we got to this stage, we can actually see the vocabulary. The stage number 5 is the count vectorizer, and I can see the first word in the vocabulary. And once this finishes, I'll show you how we can map the features in H2 frame to the actual words, and we can see what words contributed the most to our model. We have so-called feature importances in H2 flow, so we can go to model and see which features influence our model the most. And I can see which words were the most important. Okay, this finished. So let me just load the prediction data. Let me switch the prediction data into Spark data frame. And let me transform the data I want to predict on using this pipeline model. And I can see I have the results right here. And the sentiment is the sentiment is, sorry, and we have there is lots of columns, but we have the negative and positive column, and we can see that the probabilities in which specify whether it's positive or negative. So let me export the pipeline model. It's instant. Let me see the word. So it's word grade. We can see that the word grade is the first one in the vocabulary. So it's the word which really influenced the model. And let me go to flow. Let me go to flow. I need to have a correct IP address. Yes. I can go model, list all models. I can see the JBM model, which was trained during the pipeline. I can click on it. It will just show the model. I can see all the matrices, all the curves, AUC curves. And what I want to show is that you have these variable importances. And for example, you have this variable with the number 0 and with it. It would still need a bit more work to clean this up, but I can see the number here, the 0, which maps to the first number in the vocabulary. And I can see that it's great. So the word grade influenced my model the most. Okay. And now I'll wrap this up like with Jupyter Notebook, and what I just want to show is the streaming application. You can actually run it from Jupyter. I will show it from my laptop because it's more complex to set up the JVM environment. But I just want to demonstrate what it can do. So I'm going to simulate myself input data. Let me just show you the code. So there is an IntelliJ for you. Let me make it bigger. How do I make this code bigger? Oh, this no. There's presentation mode, enter presentation mode. Yes. So we have a few lines here. This is a Spark application in Java, in Scala. I'm just turning annoying logging, so I just see the messages I need to see. I define Spark session. I load the pipeline model, which I defined using the PySpark, and I also load the schema file I created. So I just load it from the schema JSON file, and then later I create input data stream, which will load the data iteratively from this folder. It will look for new CSV files, and it will run the pipeline model here because I specify that this input data stream is input to the pipeline. And then I can output the data into memory or into the disk. In our case, I will output into memory, and I will create predictions table out of it, and I can see how the data comes online in this Spark in this session. So for this, let me simulate the data. I have this simple shell script which will start streaming the data. It actually opens the reviews prediction CSV file, and it will output line after line into the folder where it's expected for the input data stream. So let me just start streaming. Okay, data are going on. And let me execute this presentation mode and start the application. So it will run the model, it will load the model, load the schema.json file, create input data stream, create output data stream, and it will run the pipeline on it. And we can see that it's looking for new files and running predictions on it. So it's actually a real streaming pipeline, and it's really easy to deploy. We define it in Python, and then we decided to deploy it in Scala because it's a more robust environment, maybe where people can deploy the applications. And we can see that the more rows are coming, and we just run predictions on them. Okay. And that was it, what I wanted to show. So you can also get other resources from our website, from our YouTube. We have also booklets available. They are free to take. And that's it. So if you have any questions, I'm happy to answer them. Oh yeah. This is maybe better.
Is there a link to this presentation that you just run?
Yeah, if you go to Quick Lab, where you just started, there is a link to the presentation. No, we will share it later. Oh yeah, we already have it there. I didn't see it. Can we still access the notebook after the lab session? This notebook inside of Spark repository, inside of our H2O repository, on H2O tutorials, there is a link on the Quick Lab where you can get the address of this notebook. Maybe we can share it later as well too, so you have this notebook available, and I can also share the Scala code. The other question is, does Flow treat Spark data frames differently from H2O data frames? Flow is just a user interface, and it doesn't actually execute anything on the frames. And it's natively built for H2O frames. So you can see the H2O frames, but you can't see the information, the detailed information about Spark data frames. So Flow was just built for H2O. You can list Spark data frames in H2O Flow because of the integration, but we can't get like clear insight of the information. For this, we need to switch to H2O format. Can you show a PySpark example of spinning up the Spark motor cluster? I just did that. This was the call H2O context get or create right here. Yeah, so this code actually starts the Spark motor cluster, H2O cluster inside of Spark. Oh yeah. Can I use Scala Spark in place of PySpark? So PySpark is just Python wrapper for Spark. And you can, of course, use Scala. You can do the pipeline in Scala. It's natively supported. All the stages I just did, you can define them in Scala using Spark and Motor. They are supported. And that's it. That's all the questions I can see here. So just do me one more favor. Before you leave this stage, just close the Quick Labs, stop the labs, so other people can use these Quick Lab sessions later. So if you don't need those sessions, just please close them, and that will help us a lot. Thank you.